In this video, I want to show how you can get the balance point of a meter bridge without carrying out the experiment. One of my subscribers, Jamil, asked me to perform or show this method of determining the balance point on the meter bridge without carrying out the experiment. So I am going to show you that. Now let's look at this, where I have the circuit and I have a known resistance of 1 ohm connected on the left hand side of the meter bridge, and I have a resistance bus or a variable resistor connected in parallel with an unknown resistance X. Now, for you to be able to carry out this experiment or carry out this manipulation using the formula, you should be able to know the value of X. So you have to know beforehand the value of X. So if you know the value of X, then you can apply the formula to obtain the balance point L and subsequently evaluate 100 minus L. Now for the resistance bus, I'm going to plug or unplug various resistance from there. Now as you can see, I have the balance point on the left hand side as L and on the right hand side as 100 minus L. So these are the resistance that I'm going to unplug from 1 to 5 on the resistance bus. Then I'll combine, then I will obtain their balance point L and consequently evaluate 100 minus L. Now this is the formula that I'm going to use for a parallel combination of two resistors. The combined resistance, which I'm calling R sub T or R total, is equal to the product of the two resistance R1, R times R2 divided by the sum of the resistance. So let's assume for here I have the resistance S to be equal to 2 ohms. So if I already know the resistance S to be equal to 2 ohms, then I apply the formula R2 equals R1 times R2 divided by R1 plus R2. So if I set the resistance bus to be R1 and X to be R2, then the 1 ohm resistor to be R3, then I'm going to obtain, for the first part, I'm going to set R, that's the resistance of the resistance bus, to be equal to 1. So once I set that to be equal to 1, then I apply the formula. So R total is going to be 1 times 2, that is the resistance of the resistance bus times the resistance X divided by 1 plus 2, and that's going to give us 2 divided by 3, which is equal to 0.67 ohms. Now if I set R, that is the resistance of the resistance bus, equal to 2 ohms, then the total resistance R sub T is going to be equal to 2 times 2 divided by 2 plus 2 and that is going to be equal to 4 divided by 4, which is equal to 1 ohm. Then I'm going to set R equal 3 ohms and R total is going to be equal to 3 times 2 divided by 3 plus 2, which is equal to 5. So that's 6 divided by 5, which is equal to 1.2 ohms. Now if I set R equals 4 ohms, I'm going to have R total is going to be equal to 4 times 2, which is equal to 8, divided by 4 plus 2, which is equal to 6, and that result will give us 1.33 ohms. Then if I set R equals 5 ohms, I'm going to get R total is equal to 5 times 2 divided by 5 plus 2, which is equal to 7. That'll give us 10 divided by 7. That'll give us 1.43 ohms. So let me just demarcate this so that I have space to for the derivation of the other formula. Now you see the combined resistance on the right hand side, that is the resistance between the parallel resistors. I'm going to call that R sub T, which is R total. So we're going to apply that on the left hand side and apply the 1 ohm on the right hand side, and these values corresponds to this value that we have just calculated here. So for each of these values, we are going to get the balance point L and the corresponding 100 minus L. So for the meter bridge formula, we have R1. So I'm going to call that R3 now. So my R1 is going to be R3, all right, divided by R total is equal to L divided by 100 minus L. So we know the value of R3 to be equal to 1. So I'm going to have 1 divided by R total. Now I am using that one because it is constant throughout. Is equal to L into 100 minus L. So all I need to do is to cross multiply. When I cross multiply, I'm going to have R total, or rather 100 minus L, is equal to R total, or L times R total. So from here I'll collect like terms. That means I'm going to bring L to the right hand side. So I have 100 is equal to L times R total will give us R total L plus L. So I'm going to factor out L out of this. When I factor out, I'm going to have 100 is equal to L into R total plus 1. So from here you can see that L is going to be equal to 100 divided by R total plus 1. So what I've done here is to write the values of R total, then we'll just plug all of them into the formula L equals 100 divided by R total plus 1. I did this so as to have a lot of space to put this. So when R equals 0.67, my L is going to be equal to 100, or I call L1, which is going to be 100 divided by 0.67 plus 1. That's going to give me 1.67. 0.67 plus 1. That's going to give me 0.67. 1.67 rather. So when I divide this, my result is going to be 59.9 centimeter. So to look for L2 is going to be equal to 1 plus 1. That's give us 100 divided by 2, which is equal to 50.0 cm. So for L3 is going to be equal to 1.2. 100 divided by 1.2 plus 1. So that will give us 100 divided by 1.2 plus 1 is going to be 2.2, which is equal to 45.5 ohms. So I have already done for L4. So we have L4 is going to be 42.9. That is 1.33 plus 1. That gives us 100 divided by 2.33. And for L3, I have 100 divided by 2.40. So I've just filled the values in the composite table for that. So the next thing I have to do is to evaluate all of that. That is 100 minus L for the first part. 100 minus 59.9 is going to give me 40.1, and so on and so forth for the others. So you can easily evaluate that by subtracting the values of L from 100 to obtain this.